Welcome to IronHand Tech. Every year, over 50 million tons of glass are produced worldwide, and most of it is used in the beverage and food industries. About 70% of the global glass production becomes waste after just one use, especially single-use bottles. In the US alone, more than 12.3 million tons of glass were discarded in 2018, and only about 3.1 million tons, or 25.3%, were recycled. Glass has an interesting feature. It's inert, meaning it doesn't react with whatever's inside it, and it also means it doesn't break down in landfills. It could take millions of years for glass bottles to degrade. The good news is that glass can be recycled infinitely without losing quality. Now let's explore this magical recycling process from start to finish. Like every great story, it starts with the basics. The materials. Used glass, mostly from bottles and jars, is collected from recycling centers or bins. This is the most important step, and it's something every one of us can contribute to: sorting waste. Once the glass is cleaned, it's crushed into small pieces called cullet. Cullet is the primary material for making new glass. Crushing the glass speeds up the melting process, saves energy, and makes the material easier to handle in the next steps. Screening machines help sort glass by size, with larger pieces being separated and crushed again for the recycling process. We still have bottle caps mixed in there, so our trusty magnetic separator steps in to remove any metal contaminants. This machine pulls the metals out of the mix and collects them in a separate bin, ready for recycling in another special process. Using cullet in production significantly reduces the need for raw materials and lowers the required melting temperature, saving energy and reducing CO2 emissions. About 1 ton of recycled glass saves up to 315 kilograms of CO2 and 40% energy compared to using new raw materials. The crushed glass is then sent to the dryer. The dryer helps remove moisture and lightweight contaminants like paper, plastic, and dust from the glass. Optical sorters help distinguish brown glass or ceramic fragments. If brown glass gets mixed into the production of clear or green glass, it can alter the color and lower the value of the final product. Even a tiny bit of brown glass can cause issues because it doesn't blend perfectly with clear or green glass. And as for ceramics, they don't melt at the temperature that regular glass does. After being sorted and cleaned, the glass moves to the crushing machine, where it is ground into fine powder, ready for the next step. The powdered glass is then mixed with other raw materials to create new glass. The raw materials include silica sand, about 50%, soda ash, and limestone. The ratio of these components can vary depending on the type of glass product being made. And now things really start to heat up. Literally, the furnace temperature is a whopping 1,600 degrees Celsius. If you're imagining a giant microwave, well, you're not far off. This is where our mix of sand and broken glass turns into something shiny and bubbling. We call it GOG, a strange but fun term to describe molten glass. Turning the furnace on and off consumes a lot of energy, so the furnace runs continuously 24/7. Glass was first discovered and used around 3,500 BCE in the ancient civilizations of Mesopotamia and Egypt. However, it wasn't really invented by humans. It was discovered by accident. There's a legend that glass was discovered when Phoenician merchants stopped by a beach and used limestone to build a cooking fire. The high heat melted the sand and limestone, accidentally creating glass. Around 50 BCE, the technique of glass blowing was invented in the Syro-Palestinian region, marking a significant milestone in the history of glass. By the 19th and 20th centuries, industrialization and the advent of recycling technology made glass a ubiquitous material, allowing faster and more efficient production. This development made glass a common, widely used product in everyday life. Now things start to get interesting. We're not just making glass. We're turning it into the perfect bottle that you can hold in your hand, take a sip of something cool and think, wow, how was this made? And right here, at this moment, molten glass is poured into a mold, air is blown in, and voila, a glass bottle is born. There are two methods to make this happen: blow and blow, or press and blow. The blow and blow method is used for narrow-neck bottles like beer and wine bottles. First, the molten glass is cut into small sections and placed into a mold to form a preliminary shape called a parison. Then the parison is blown a second time to complete the bottle's shape. The press and blow method is often used for products with wider necks. Molten glass is pressed into a mold to create the initial shape, and then air is blown in to form the final shape of the bottle. But we're not done yet. You see, freshly blown glass can't immediately withstand the harshness of the outside world. It needs a little time to recover. Just like we need to rest after a stressful meeting, glass needs to cool down slowly. And now it's time for the all-important quality check. The finished glass bottles are inspected using automatic devices to detect defects like cracks, bubbles, or other flaws. These machines can spot the tiniest imperfections that the naked eye can't see. After inspection, glass bottles usually undergo surface treatment by applying a protective coating to increase durability and reduce friction during transportation. This helps minimize the risk of scratches or breakage during storage and shipping. And so, from those old shards of glass, from those bottles that seem to have reached the end of their journey, they have been reborn, ready to serve once more. Recycling isn't just about creating something new from the old. It's a journey of sustainability and responsibility, and it all starts with sorting waste, a small act that brings tremendous benefits. Hello everyone, and welcome to IronHand Tech. Today we're diving into a fascinating and crucial journey in the battle against waste, recycling old fabrics. But before we get into the nitty-gritty of each stage, Let's take a quick look at some eye-opening numbers to understand the current situation better. Every year, around 92 million tons of textile waste are dumped into the environment globally. That's equivalent to a truckload of old clothes being discarded every second. And here's the kicker. Most of it will never fully decompose, especially synthetic fabrics like polyester. Those old shirts we forget about could outlive an entire generation. Textile waste doesn't just take up space in landfills, it also significantly contributes to environmental pollution, from contaminating the soil to polluting groundwater and even the air. According to a report by the U.S. Environmental Protection Agency, EPA, an estimated 11.3 million tons of textile waste ended up in landfills in the United States in 2018 alone, making up 7.7% of all municipal solid waste. Meanwhile, a report by the World Bank shows that the textile and fashion industry is responsible for around 20% of global industrial water pollution. The production of new fabrics also consumes a vast amount of resources, such as thousands of liters of water to produce just one cotton shirt, not to mention the energy and chemicals involved. So what is fabric recycling? Simply put, it's the process of turning old, outdated, or damaged clothing into new products, or, at the very least, recycling materials to be used in other industries. Fabric recycling not only helps reduce waste, but also saves resources and minimizes environmental impact. In today's video, we'll go through the entire process, from collecting old clothes, through processing, to transforming them into new products. And most importantly, we'll explore the modern machinery used in each stage and why they're so vital. Get ready to discover a world we rarely see, but one that plays a crucial role in our everyday lives. The first step in the fabric recycling journey is collection. Have you ever wondered where all those old shirts and ripped jeans go when we no longer need them? Don't worry, not all of them end up in the landfill. Old clothes are collected from various sources: households, fashion stores, and charitable organizations. Some people choose to donate their old clothes to those in need, while others drop them into recycling bins scattered throughout cities. There are even regular clothing collection events to encourage people to participate. Once collected, the clothes are sent to sorting facilities. This is a critical step in the recycling process. Here, the clothes are sorted based on material, color, and condition. Fabrics like cotton, polyester, wool, and silk are separated because each type requires a different recycling process. To do this, both modern technology and human labor are used. Optical scanners and sensors are among the key tools that help automatically sort items based on color and material. These scanners can detect and sort thousands of items in just minutes, a task nearly impossible if done manually. However, in many cases, manual sorting is still necessary, especially for complex fabrics or items with multiple layers of different materials. Why is such detailed sorting necessary? Because each type of fabric undergoes a different recycling process, and accurate sorting optimizes this process. If a polyester shirt is mixed with a pile of cotton, the recycling process will face difficulties, leading to lower quality or even unusable final products. Sorting is not just a preparatory step, it's a decisive factor in the success of the entire recycling process. After sorting, the clothes undergo pre-processing before being recycled. You can imagine that old clothes aren't always clean and ready to be recycled immediately. They need to be cleaned and have any unwanted parts removed. The first step is cleaning. This isn't as simple as doing laundry at home. It's a complex industrial process. Industrial washing machines are designed to handle large volumes of clothing at once, using strong water pressure and specialized detergents to remove dirt, grease, and other contaminants. Some modern technologies even use biological enzymes to break down organic stains, making the cleaning process more efficient without needing excessive chemicals. Next is the removal of unwanted components like buttons, zippers, and other metal accessories. This step is crucial because if these parts remain during recycling, they could damage the machinery or reduce the quality of the final product. After pre-processing, the old fabric is ready for the fiber processing stage. This is where your old clothes start to transform into new materials. The first step is shredding. The old fabric is fed into an industrial shredder where it's torn into small fibers. This shredder is like a giant metal monster with sharp blades spinning at high speeds, tearing everything into fibers. These fibers are then separated by material using a fiber separator, which helps accurately classify the fibers so they can be easily recycled into new products. The fiber separator is one of the essential tools in this process. It helps separate different types of fibers without damaging their structure. This process requires high precision and speed because time is a critical factor in industrial production. Once separated, the recycled fibers are moved to the next stage of fiber processing. Here, the small fibers are combined to create new threads through a spinning machine. This machine is similar to a weaving machine, but with much greater capacity, capable of spinning thousands of meters of thread in an hour. This process requires a perfect balance between speed and durability, as if the fibers are spun too quickly, they'll break, but if too slowly, the process won't be efficient. Spinning machines are designed to ensure that each thread produced is of consistent quality and strong enough to be used in new products. However, processing recycled fibers isn't always straightforward. Some fibers, like polyester, need to be melted before they can be spun into new threads. The melting machine operates at very high temperatures, liquefying the polyester fibers before molding them into new threads. After being processed into new threads, we move on to the weaving stage. This is where the recycled threads are turned into new fabric sheets, ready for various applications. The industrial weaving machine is the heart of this stage. With modern weaving machines, thousands of threads are connected and woven into large sheets of fabric in just a few hours. These machines can weave at incredible speeds, but without sacrificing precision. Every thread, every stitch is carefully calculated to ensure the final product's quality. Once the fabric sheet is woven, it goes through the finishing stage. This stage includes several smaller steps, from cutting, sewing, dyeing, to the final quality check. Automatic cutting machines help cut the fabric into smaller pieces, ready for the sewing or further processing steps. Dyeing is also an essential process. The dyeing machine uses special dyes to create fabrics with bright and durable colors. This not only makes the recycled fabric more attractive, but also makes it suitable for various applications, from fashion to industry. So after all these complex steps, what can recycled fabric be used for? The answer is a lot of things. Recycled fabric can be used to produce new clothing, textile products, carpets, insulation materials, and even in construction. With each sheet of recycled fabric, we not only reduce waste, but also save resources and energy compared to producing new fabric from raw materials. Moreover, with technological advancements, recycling old fabric is becoming more efficient and environmentally friendly. Research is focusing on developing enzymes and bacteria that can quickly and safely decompose fabric, opening the door to new recycling methods. The future of fabric recycling is bright. With efforts from scientists, engineers, and even consumers, we can hope for a world where old clothes are no longer a burden on the environment, but a valuable resource that drives the circular economy and protects our green planet. Thank When an old building is demolished or a worn-out road makes way for new construction, have you ever wondered what happens to all that leftover concrete? Those gray slabs aren't just left sitting in landfills. They're about to embark on a new mission. The reality is that concrete makes up nearly 50% of construction waste in major cities. In the United States alone, about 300 million tons of concrete waste are produced each year. And worldwide, that number can reach billions of tons. Imagine this. Instead of going to waste, these concrete blocks are crushed into smaller pieces, carefully screened and treated, then transformed back into building material. They're not just forming new roads, but also helping to conserve resources and ease the environmental burden. In this video, you'll see every step in concrete's revival journey, from massive crushers to advanced filtration technology, all working together to create a sustainable cycle of rebirth. Not only does recycling concrete help reduce waste, but it also has significant resource-saving benefits. To produce new concrete, we have to extract stone, sand, and cement. This process not only consumes energy, but also releases a large amount of CO2, contributing to the greenhouse effect. Statistics show that every year, the world produces about 5 billion tons of cement, with the cement industry contributing around 8% of global CO2 emissions. Each ton of recycled concrete can save hundreds of kilograms of CO2 compared to producing new concrete. Thus, a highway project using thousands of tons of recycled concrete will significantly reduce emissions, equivalent to planting tens of thousands of trees. One of the biggest benefits of recycling concrete is cost savings. Using recycled concrete can reduce costs by 20 to 30% compared to using new concrete. For large projects like highways, the savings can reach millions of dollars. These savings not only reduce construction costs, but also free up funds for other projects. For example, a 10-kilometer highway project using recycled concrete can save around $2 to $3 million compared to using all new concrete. The process begins with collecting concrete debris from demolition sites. Each large building can generate 1,000 to 2,000 tons of concrete waste. After collection, the concrete is transported to a recycling plant, where it undergoes a strict sorting process. A magnetic separator is a powerful and useful device, helping to remove magnetic impurities like steel. Without this equipment, remaining steel bars could damage the crusher and reduce the quality of the recycled concrete. Magnetic separators have a precision rate of up to 98%, removing almost all leftover steel. Additionally, wood and plastic, which are also undesirable materials, are sorted out during this stage. Concrete is crushed into particles ranging in size from 20 to 30 millimeters, for base layers and 10 to 15 millimeters for pavement layers. A crusher can process up to 500 to 600 tons of concrete daily, ensuring a continuous supply of recycled concrete. Crushing concrete is really heavy-duty work. Imagine that this crusher can crush even the largest concrete blocks, like the superhero of the construction industry. After crushing, the concrete is screened to ensure uniform size. Oversized particles are sent back to the crusher, while the particles meeting standards move on to the next step. The mixture is passed through a magnetic separator again to remove any remaining magnetic materials, and the concrete is cleaned with water. By the end of this process, we have concrete ready to be used as building material. To ensure the durability and high quality of recycled concrete, the crushed concrete is mixed with new cement, sand, stone, and water at a precise ratio. Depending on technical requirements, the proportion of recycled concrete in the mix can vary from 20% to 50%, combined with virgin cement and aggregates to create new concrete. Concrete is commonly used for road-based layers. This base layer helps distribute load, increase road durability, and create a stable surface. After the concrete has been thoroughly mixed and quality checked, it is transported from the mixing station to the construction site by mixer trucks. These trucks typically have capacities from 6 to 10 cubic meters to ensure the concrete doesn't separate or lose moisture during transport. During transport, the drum on the truck rotates continuously at a low speed, around 2 to 6 rotations per minute, to ensure the concrete doesn't harden before reaching the site. Once on site, the concrete is poured into pre-prepared molds along the road's route. These molds are usually sized to fit the highway width, typically 3.5 to 4.5 meters per lane. After pouring, a grater smooths the concrete surface to achieve the desired thickness. The thickness of highway concrete layers typically ranges from 20 to 30 centimeters, depending on the load-bearing requirements of the road. To create compaction and a stable structure for the road surface, a vibratory roller is used. This roller can weigh between 10 to 15 tons, ensuring the concrete is uniformly compacted with no air voids. After compaction, the concrete surface is treated to create texture, which enhances road grip and reduces slipperiness for vehicles. A texture machine is used to create small grooves on the surface. These grooves, typically 3 to 5 millimeters deep, are made either horizontally or diagonally to optimize drainage and grip. After pouring and finishing the surface, the concrete requires a curing period to reach its optimal hardness and durability. Curing may take from 7 to 28 days, depending on weather conditions and technical requirements. Recycling concrete on a large scale is no easy task. Transportation and impurity processing costs are considerable challenges. Another challenge in recycling concrete is ensuring material consistency. Concrete recovered from different projects often has varying composition, particle size, and strength. This makes it difficult to create a recycled concrete mix with stable, uniform quality. Uneven particle size can affect the density of the concrete, while variations in chemical composition can reduce the strength and durability of the structure. To address this issue, Careful sorting and processing steps are required, along with appropriate concrete mixing formulas to ensure uniformity in the final product. By using recycled concrete, we not only save costs, but also contribute to the goal of sustainable construction. For every kilometer of highway, recycled concrete helps reduce tons of CO2 emissions, conserve natural resources, and create a sustainable foundation for the future. We've seen that old, worn-out concrete can be reborn and become a part of modern roads. Every time you drive on a highway, remember that it may have been created from the legacy of the past, a wonderful example of the life cycle of building materials. Can you believe that these boards are made from the milk cartons you use every day? Milk is an essential part of our lives. Every day, millions of people worldwide consume milk, juice, and other products packaged in these cartons. After use, these cartons are typically discarded, with little thought given to where they end up. But would you believe that these milk cartons can actually be transformed into bricks or roofing materials? In this video, we'll delve into the process of recycling milk cartons, exploring how they're separated, processed, and ultimately converted into valuable building materials. The milk cartons we use daily aren't just simple paper containers. They're actually a complex product made up of three main layers: paper, polyethylene plastic, and aluminum. The majority of the carton, around 70 to 80%, is paper, which provides sturdiness and protects the contents inside. The polyethylene layer acts as a waterproof barrier to keep the milk from leaking, while the thin aluminum layer prevents oxygen and light from entering from outside. However, the multi-layer construction of milk cartons poses a significant recycling challenge. These layers are tightly pressed together, making separation difficult without advanced technology. Because of this, many places are unable to recycle milk cartons efficiently, leading to the majority being sent to landfills. But with technological advancements, we can turn these challenges into opportunities. Milk cartons can be separated into individual components, each of which can be recycled into new products, including building materials. The recycling process begins with the first step: collection and sorting. Used milk cartons are collected from households, schools, restaurants, and even manufacturing facilities. They're then brought to recycling centers where workers and machines start sorting them. Here, the milk cartons are inspected to remove any damaged or non-recyclable ones. The remaining cartons proceed to the next stage. Automated sorting systems use sensors and cameras to detect unsuitable materials, while workers perform a final check before compacting the cartons to save space for transportation to the recycling plant. Every day, hundreds of tons of milk cartons are collected from around the world and fed into the recycling process. These efforts help reduce millions of tons of unnecessary waste sent to landfills and significantly minimize environmental pollution from milk cartons. Upon arrival at the recycling plant, the milk cartons are shredded. A giant blender equipped with sharp blades cuts the cartons into small pieces, each about 10 to 20 millimeters in size. A typical shredder can handle 500 kilograms to 2 tons per hour, depending on its size and capacity. The paper dissolves in water, forming a pulp, while the plastic and aluminum either float or sink, depending on the material properties. Next, filters with varying sizes separate these components. Differences in size, weight, and in material properties allow the plastic and aluminum to be isolated. Once separated from the milk cartons, the pulp is processed at paper recycling plants. This is a crucial step to repurpose the large quantity of paper contained in each milk carton. At the plant, the pulp is cleaned and bleached if necessary before being used in new paper production lines. These recycled paper products serve various purposes, from toilet paper and cardboard to notebooks for students. Every ton of milk cartons can yield around 700 to 800 kilograms of recycled pulp, depending on the quality of the original material and processing method. By recycling, we reduce the demand for new paper, saving millions of trees each year. Aluminum and plastic are the two remaining key components after the paper has been separated. These materials can be recycled into new products, particularly for the construction industry. Once separated, the plastic and aluminum are shredded and passed through a filter to remove any remaining paper pulp. Hot air dryers eliminate moisture from the mixture, which is then further ground down. Now an extruder machine steps in. The plastic and aluminum mixture is heated to 392 degrees Fahrenheit, forming a uniform, durable, waterproof, and weather-resistant composite. This mixture is poured into molds, and hydraulic presses shape it into products of various forms and sizes, including paving stones, roofing sheets, and plastic boards for construction projects. A thermal press can produce thousands of paving stones daily with high load-bearing capacity and exceptional durability. Plastic boards made from the aluminum-plastic mix find multiple construction applications, from flooring to insulation panels. Products made from recycled aluminum and plastic are becoming increasingly popular in construction, not only for their durability, but also for their eco-friendliness. Paving stones made from milk cartons are water-resistant and sturdy, making them ideal for outdoor projects like gardens, sidewalks, and pathways. Roofing sheets and plastic boards are also widely used in residential and industrial construction projects, serving as alternatives to traditional materials like wood and metal. Their use helps reduce natural resource extraction and promotes sustainable development. Recycling milk cartons not only helps decrease landfill waste, but also conserves resources and energy. Every ton of recycled milk cartons recovers hundreds of kilograms of aluminum and plastic, significantly cutting carbon emissions from landfilling and new production. By recycling, we save raw materials and protect the environment from pollution caused by waste disposal. This is crucial as resource demand rises and landfills become increasingly overburdened. Remember, every milk carton you sort and recycle could become a paving stone, a plastic board, or even a part of a sustainable construction project. Start with small actions, like sorting your waste and contributing your milk cartons to the recycling process. Welcome to IronHand Tech. Today we are going on an exciting journey of recycling old cars, where old cars, which seem to be just waste, become valuable resources. Have you ever wondered where our old cars, once our pride, go when they no longer run? Let me explore this magical transformation process. Recycling is not just about processing scrap metal into new products, but also about the story of regeneration and protecting our planet. But first, why should we recycle old cars? What is so special about these cars that have served us for decades? First, let's talk about the environment. Not only do old cars take up a lot of space in landfills, they also contain a lot of toxic substances. If not disposed of properly, they can pollute the land and water. Recycling cars helps reduce this toxic waste. According to statistics, recycling steel from cars can save up to 74% of energy compared to producing new steel from raw materials. This not only reduces CO2 emissions, but also saves precious natural resources. And for comparison, recycling just 6 cars is enough to build a brand new steel frame house. Second, the economics. An old car is more than just a pile of scrap metal. The average car is about 65% steel, 8% aluminum, 16% plastic, and many other materials, all of which can be reused. Recycling helps us recover these materials, reducing waste and creating new economic value. Recycling old cars also creates jobs for thousands of workers. According to the U.S. Environmental Protection Agency, EPA, the auto recycling industry contributes billions of dollars to the economy each year. Now let's take a look at the process of recycling an old car. Brace yourselves because we are about to embark on a journey that is no less exciting. First, workers will disassemble everything possible from the car. The dismantling process requires meticulousness and high technology. Valuable parts such as the engine, gearbox, and tires will be reused or resold. At the same time, hazardous waste will be treated according to regulations to avoid polluting the environment. Statistics show that about 80% of the parts of an old car can be reused or resold. Next, all fluids such as oil, fuel, coolant are drained and safely disposed of. It is estimated that an average car contains about 40–50 liters of fluids, which if not disposed of properly can cause serious pollution. After dismantling, the car is pressed and fed into a crusher to be crushed into small pieces. Crane operators will lift a car and put it into the crusher. In just a few seconds, the car will be turned into a loaf of steel. The cars are then fed into the crushers via a conveyor system. These are hungry steel giants, with their sharp, toothy mouths always wide open and their terrifying power of hundreds of tons of crushing force. Within minutes, the car goes from being intact to being reduced to metal scraps. Statistics show that every year, about 12–15 million used cars are crushed in the U.S. These scraps are then sorted and transported on a conveyor system, which has 2 conveyor belts, each with 2 magnets, the purpose of which is to separate the steel from the remaining materials inside the car, such as plastic, copper, leather seats, electrical wires. About 75% of the weight of an old car can be recycled into new materials. The steel scraps are further carefully sorted to obtain the cleanest steel before entering the recycling stage. The sorted metal is fed into the melting furnace. The steel pieces are fed into the arc furnace, where the electrodes are equipped with a high-power electric source that creates an arc that ionizes the surrounding gas particles to form plasma. The high temperature of the plasma melts the steel. The electrodes are constantly adjusted to maintain a stable arc and melt the entire block of steel. The molten steel is then refined and cast, poured into a specially shaped mold, and cooled slowly to form a steel billet. From here, the steel is processed into coil steel or other types of steel according to its intended use. This process helps us recover about 15 million tons of steel each year from old cars in the US. And so from old cars, we have new steel bars, ready for a new life. Recycling steel from cars helps to significantly reduce greenhouse gas emissions compared to producing new steel, contributing to environmental protection and creating significant economic values. Recycling cars is not only an industrial process, but also an act of environmental and resource protection. Every old car, no matter how many years it has served us, still has value and potential for a new life. Welcome to IronHand Tech Channel. Today we will go through a very interesting recycling process that you cannot imagine. First of all, to make this video experience more interesting, let's predict the results of this process. Answer this question. In your opinion, what can scrap iron be recycled into? A. Construction steel. B. Cast iron cooking pot. C. Harrow disc. Keep the answer in mind and watch the video until the end to find out the answer. Here we are in a metal recycling plant. The environment is quite primitive and the workers often lack proper protective equipment. Unlike plastic bag scrap, iron and steel scrap is much larger and heavier. Therefore, sorting and collecting it requires a lot of effort and time. The first step in the metal recycling process is scrap metal collection. In Pakistan, a significant portion of metal waste is imported. Pakistan imported 455,000 tons of ferrous scrap from the United States last year. Workers will sort the scrap, cutting them into pieces of suitable size for the recycling process. Raw metal is a common type of waste in the industrial production process, including steel plates, damaged or unusable products, scrap from the production process, etc. The metal pieces are sent to a furnace. Unlike other recycling processes, the iron is not melted. It is heated to a temperature that allows it to be flattened, around 700–900 degrees Celsius. The red-hot iron bars are fed into the press. Here, in an extremely manual manner, the iron bars are pressed repeatedly on the press to achieve the appropriate flatness. This can be called a hot rolling process. For those who don't know, when iron is red hot, its crystal structure changes, making the iron more flexible and easily deformed under the influence of external forces. This drum continuously rotates and presses the red-hot iron bar into a flat, square iron plate. I wonder what kind of superior skill these workers have that keeps them from getting burned while working. The iron sheets are now fed into the cutting machine. They are cut into round iron sheets. Once again, they were put into a furnace. This machine made a square-shaped hole in the center of the iron. Now you guessed it, it was Captain America's shield. Of course not, I'm just kidding. These iron plates are polished, heated again, and given another hole, this time on the outer edge. Now they are polished again, then they are painted with several layers of paint. You can probably guess what this process is all about. And here is our finished product. These are the Harrow discs. Let me personify this Harrow. From a distance, the Harrow looked like a giant monster moving slowly. A series of shiny, round discs rotated regularly, creating streaks of soil that were thrown up and then dropped down. With each rotation of the discs, the hard surface soil seemed to be torn up and broken into pieces. A little closer, we could see more clearly how the discs were plowing the soil. They cut into the ground, crushing the hard clumps of soil, stirring them up and down. Each time the disc rotated, the soil was loosened a little more. The grooves created were neat, like lines drawn on a painting. Isn't that interesting? You may not believe it, but this manual steel recycling process can reduce CO2 emissions by up to 70%. It's great that our workers not only create new products, but also contribute to protecting the environment. Facilities like these contribute to the local economy by creating jobs and reducing the need to import raw materials, as well as tackling the widespread waste problem. So recycling metal is not only about turning waste into valuable resources, but also protecting the environment, conserving energy, and supporting the economy. Welcome to IronHand Tech Channel. Polyethylene, PE, is one of the most common plastics, and PE plastic bags are widely used in daily life. However, these plastic bags are often abandoned after use, causing a large amount of plastic waste and having a negative impact on the environment. In today's video, we will learn about a very interesting plastic bag recycling process, where old PE plastic bags are transformed into a very useful new product. Watch this video to find out what that product is. The United Nations estimates that the world uses about 5 trillion plastic bags every year, or nearly 10 million bags every minute. This means that every day we throw away hundreds of millions to billions of plastic bags globally. In some countries like the US, it is estimated that each person uses an average of about 1 plastic bag per day. And this number may be higher in developing countries. Therefore, the amount of plastic bag waste is extremely large, and we need a recycling solution to limit their impact on the environment. We are at a local factory where the machinery is quite rudimentary and the workers work in poor conditions. Plastic bags are collected from landfills, households, or plastic collection facilities, and then gathered at this factory to prepare for the recycling process. These plastic bags are put into a high-temperature melting furnace. This melting process turns PE plastic from solid to liquid, creating conditions for recycling into new products. This is a special machine. It maintains the temperature with wood and broken shoes. The recycling process at this factory gives us a sense of pollution and danger. However, in some places, factories like this provide jobs and solve the waste problem quite effectively. After being melted, PE plastic is cut into small cakes. They are cooled with water to prepare for the next process. In some developing countries, waste recycling is an important industry, mainly because of the abundant and cheap input materials. However, the polluted working environment and its consequences for workers' health are things that need to be concerned. The PE plastic cakes are put into the crusher, where they are crushed to make the plastic injection process more convenient. Here we have PE plastic particles with sizes ranging from 2 to 5 millimeter. The final step in this recycling process is to use recycled PE plastic pellets to produce water pipes. The plastic pellets will be fed into the extruder, where they are melted at temperatures ranging from 120 to 180 degrees Celsius. This machine melts the plastic pellets, then through this long iron pipe, the molten plastic is extruded through the forming die to form the water pipe. The plastic pipe is continuously cooled after leaving the machine and continues to be shaped. Now our product is completed. These recycled PE plastic water pipes have good flexibility and strength, although they are not as good as virgin PE plastic pipes. They are often used in applications that do not require high quality, such as irrigation water, wastewater, or temporary purposes. The water pipes are cut into suitable sizes and sent to consumption. The indirect recycling of PE plastic bags into water pipes is a good example of how we can turn waste into valuable products. Plastic bags are one of the most polluting products in the world. Plastic bags are difficult to decompose, causing clogged drains, water, soil, and air pollution. So this process, although rudimentary, shows us that solving the problem of plastic bag pollution is possible with the cooperation of the whole society. Let's build a more sustainable future together, where every old plastic bag can become part of a circular system benefiting both people and the planet. We have just explored the process of recycling plastic bags into water pipes. What do you think about this video? Please leave a comment below. If you like this video, please like, share, and subscribe to the channel so you don't miss other interesting videos. Welcome to the IronHand Tech channel. Each year, hundreds of millions of bullets are used in military operations and training. Ammunition is not only a vital part of combat activities, but it also generates massive waste. From shooting ranges to battlefields and military bases, bullet casings accumulate quickly, creating not only safety concerns but also environmental problems. Most bullet casings are made from brass, an alloy of copper and zinc. Thanks to its high durability, corrosion resistance, easy machinability, and low sparking risk. However, if not handled properly, these casings start to degrade and release heavy metals into the environment, which can harm human health and threaten natural ecosystems. So, what can we do with these bullet casings? The answer is, recycle them. Recycling not only helps reduce waste, but also saves costs, protects the environment, and provides raw materials for new production. After each training session or battle, used bullet casings are collected from shooting ranges, training grounds, and combat zones. This is a crucial step to ensure that the casings don't get lost or pose environmental hazards. At the factory, the casings are sorted by size and type, which is essential because different recycling processes require different handling for various bullet casings. Small, medium, and large caliber rounds like artillery shells each have their own recycling procedures. Modern technology allows sorting to be quick and accurate. Some automated machines can sort and inspect around 5,000 casings per hour, saving time and labor costs. Once sorted, the casings go through a cleaning process. Any dirt, chemicals, or contaminants remaining on the casings must be removed, especially to ensure that no live rounds are left behind, ensuring safety. This step is vital to maintaining the quality of the recycling process and the final product. One common method for cleaning casings is using high-pressure water and chemicals. This cleaning system helps remove impurities, grease, or any traces left from use. After the cleaning process is complete, the casings are thoroughly inspected before moving on to the main recycling stage. The next step in the recycling process is melting the casings. Copper is one of the few metals that can be recycled multiple times without losing quality. The brass from the casings is melted at high temperatures and then poured into molds to form metal ingots. These brass ingots are then used to manufacture new bullet casings or other metal products. Once the brass ingots are ready, the process of shaping new bullet casings begins. The metal is stretched, stamped, and formed into new casings. This process requires precision and modern technology to ensure the quality of the casings. After shaping, the new bullet casings are ready for use. Recycling brass not only conserves materials, but also ensures we don't waste precious resources. Not only small casings, but even large caliber rounds like 155mm artillery shells can be recycled. Artillery shells are often made from steel to ensure durability and strength. For steel casings, the recycling process includes sandblasting to remove rust and old paint. The casings are then repainted to protect them from corrosion and help identify the type of ammunition by color code. After completing the recycling process, large caliber ammunition can be reused or stored for long-term preservation. Recycling helps extend the life of the ammunition and reduces costs for the military. After completing the recycling process, large caliber ammunition can be reused or stored for long-term preservation. Recycling helps extend the life of the ammunition and reduces costs for the military. Recycled brass from bullet casings can be reused not only for ammunition production, but also in various other fields, from household items to industrial equipment. Recycling casings helps ease the strain on natural resources and reduces emissions from the extraction of new materials. This is a way the military not only saves costs, but also contributes to environmental protection. The process of recycling bullet casings is not just a story about handling military waste, it's also a prime example of how we can turn seemingly useless items into valuable resources. Every recycled casing not only saves costs, but also contributes to protecting the environment and natural resources. Each recycled casing is a small step, but when multiplied by millions, it becomes a significant change. What are your thoughts after watching this video? Let us know in the comments below. Don't Hello everyone. We all know that elections are incredibly important events where voters decide the country's future. But have you ever thought about the massive amount of waste generated from each election? That's right. After every election season, there's a mountain of waste, including ballots, signs, flyers, and so much more. So today we're going to dive into a question that might not cross many people's minds. Can waste from the US presidential election be recycled? You might be surprised. Election waste isn't just a few ballots. It's a massive pile of printed materials, signs, ads, and a lot of other items. Let's find out the answer together. And if you think that waste from an election is just a minor issue, brace yourself. We're going to cover every little detail, from ballots to signs to campaign posters everywhere. Let's get started. To understand this issue better, let's quickly review the 2024 US presidential election. This was one of the most widely followed elections, with voters concerned about various critical issues. With fierce competition between the candidates, policies on economic recovery, climate change response, and healthcare reform were hot topics. Former President Donald Trump proposed tax cuts for businesses and the wealthy, focusing on making the US a global manufacturing powerhouse. He also wanted high tariffs on imports, particularly from China. He held different views on the Ukraine conflict and had a less interventionist stance on NATO. Meanwhile, Vice President Kamala Harris aimed to raise taxes on large businesses and the wealthy, focusing on supporting workers and the middle class, while offering tax cuts for small businesses. She promised to restore federal abortion rights if approved by Congress. She stood firmly with Ukraine and NATO allies, pledged to promote peace in Gaza, and kept a distance from authoritarian regimes. The 2024 election saw increased public interest, and naturally, this also means more campaign materials. With multiple candidates competing and hundreds of millions of voters involved, from ballots to flyers to signs, all were printed and distributed on a massive scale. Just imagine millions of voters lining up to vote. You can picture the huge amount of materials these elections generate. All of these items serve their purpose for a few days and then turn into waste. So how is this waste managed? You might not believe the sheer numbers. In every US presidential election, about 100 million to 120 million paper ballots are printed. And that's just a fraction. Signs, banners, and campaign flyers from all the candidates also add to the massive pile of waste. If you stacked all that paper together, it could form a tower as tall as the Empire State Building in New York. It's true. Each ballot, flyer, and sign has its own life cycle. And then there are the countless signs along major roads, made of plastic, metal, and non-biodegradable materials. Did you know? Just to produce this amount of election paper materials, thousands of trees are cut down. On average, 1 ton of paper requires about 24 trees. With thousands of tons of paper produced each election, that's a significant number of trees lost. Imagine, this amount of paper could make 2.5 million books or nearly 50 million newspapers. That's an enormous number, all for just a few short election days. And it's not just the massive amount of paper. The production and disposal process of these materials also generates a significant amount of CO2. On average, 1 ton of paper emits around 1.5 tons of CO2 throughout its life cycle, from production to disposal. So each election not only produces thousands of tons of paper waste, but also thousands of tons of CO2, equivalent to emissions from hundreds of thousands of cars driving for a year. Election waste isn't just a few sheets of paper, it's a tower of materials, thousands of trees cut down, and a large amount of CO2 released into the environment. Who knew campaign materials had such a complicated life? So how are ballots, signs, and flyers for elections made? These aren't just ordinary sheets of paper or signs. All election materials must be produced with stringent security standards to ensure the integrity of the election. Each ballot is carefully designed with security codes, unique serial numbers, and barcodes to prevent forgery. Signs and banners are often made from durable plastic or metal to withstand use. And of course, these signs also go through thorough checks. And did you know? Each election material undergoes a strict inspection process. If there's any discrepancy, the entire batch has to be reprinted. It's not an easy job. It's a meticulous and precise task. After production and inspection, all these materials are transported to thousands of polling stations nationwide. Imagine the number of ballots and signs that need to be delivered, from large states to small towns. Every location has to be fully stocked, not too many and not too few. So, once the election is over, where do these ballots and materials go? They're not destroyed immediately. According to each state's regulations, ballots must be stored for a certain period to ensure transparency and allow for potential recounts. Some states require a minimum storage period of 22 months, while others may require storage for longer, up to several years. This ensures that if there are any disputes or recount requests from candidates or voters, the ballots are ready for verification. These ballots and election materials are stored in secure facilities, carefully monitored and sealed. It's a very strict process to ensure no errors occur. Imagine your ballot resting in storage for years, like a wedding cake kept for a special anniversary. Only no one's going to eat it. After the storage period, where do these ballots and materials go? Can they be recycled? The answer is yes, but it's not always straightforward. Before recycling, ballots and sensitive documents must be completely destroyed. This is usually done by shredding or pulverizing them to the point where no information can be retrieved. Only when they are confirmed to no longer contain sensitive information can they be sent to recycling facilities. For signs and banners, if they are made of plastic or metal, they can also be recycled. Some states even reuse signs and materials for future elections to reduce environmental impact. Once recycled, election materials can become toilet paper, cardboard, or even a pizza box. That's right, election waste can have an unexpected second life. We hope this video has given you insight into the complex journey of election waste, from production, storage, to recycling. So next time you hold a pizza box or a notebook, you might be holding part of a past election. Today, the world is facing a severe waste crisis. According to the 2023 World Bank report, humanity generates over 2.2 billion tons of solid waste annually, a figure expected to rise to 3.4 billion tons by 2050 without timely action. Amid this crisis, the recycling industry has emerged as a beacon of hope. By processing and reusing waste, we not only reduce pollution, but also conserve natural resources. At the heart of these efforts lies a powerful machine, the twin-shaft shredder. When you think of heavy industrial machinery, images of twin-shaft crushers may come to mind. But don't let their off-the-shelf looks fool you. These machines are actually artists at the job of turning worthless material into useful scrap for the recycling industry. Each twin shaft crusher is equipped with two large shafts with sharp blades, capable of crushing almost anything you can imagine. From metal, plastic, rubber, to building materials, nothing is too difficult for it. Twin shaft crushers play an extremely important role in the recycling industry. They help reduce the size of waste materials, facilitating their processing and reuse. But more importantly, they help reduce the amount of non-degradable waste, contributing to protecting the living environment. Although it looks simple, the twin shaft crusher is a sophisticated combination of traditional mechanical engineering and modern technology. The twin shaft crusher is made up of many important parts, but the most prominent element is the two rotating shafts equipped with sharp blades. The two grinding shafts of the machine are usually made of heat-resistant and high-strength alloy steel. In large industrial machines, the shafts can be 2 to 5 meters long with a diameter of up to 50 centimeters. They are designed to rotate in opposite directions, creating a strong pulling force, helping to crush any material that falls between them. The blades on the shaft are not only sharp, but also self-cleaning. When the machine is operating, they create a strong cutting force, but still ensure that they do not get stuck by difficult-to-grind materials. The blades on the shaft are not only sharp, but also self-cleaning. When the machine is operating, they create a strong cutting force, but still ensure that they do not get stuck by difficult-to-grind materials. When the material falls between the two rotating shafts, the blades start working, cutting, and crushing the material. With a strong cutting force, even hard materials such as metal or wood cannot resist. After crushing, the fragments are pushed out through the conveyor system. Some modern machines are also integrated with an automatic classification system, dividing the material by size or type. Imagine the twin shaft crusher as a giant steel jaw. Each time it chews, the material is torn into hundreds of small pieces, no different from the way a monster crushes its prey. Twin shaft crushers are mainly classified according to capacity. Mini twin shaft crushers are often used in small recycling plants where space is limited and the capacity is just enough to process light materials such as plastics and wood. For small and medium-sized recycling plants, medium-capacity crushers are the optimal choice. They can crush larger materials such as rubber or some light metals. For large-scale industrial plants, large-capacity twin shaft crushers are indispensable. They are capable of processing tons of metal waste and other materials per day. With the support of hydraulic systems, hydraulic twin shaft crushers can process the hardest materials without difficulty. This makes it an ideal choice in metal recycling industries. In the recycling industry, twin shaft crushers are one of the most important pieces of equipment. They not only reduce the size of waste, but also create raw materials for further recycling processes. Every year, twin shaft crushers worldwide reduce landfill waste by more than 30%, equivalent to 50 million tons of waste. A single high-capacity machine can process up to 100 tons of waste per day, producing enough recycled material to produce 10,000 new products. Last year alone, twin shaft crushers helped recycle millions of tons of waste worldwide, reducing industrial waste and making a significant contribution to environmental protection. One little known thing about the twin shaft crusher is that although it looks rough and powerful, inside there is an incredibly sophisticated operating mechanism. The anti-jamming mechanism is designed so that the blades not only crush the material, but also have the ability to clean themselves, ensuring no jamming. A powerful, durable, and sophisticated machine. The twin shaft crusher is not only an important tool in the recycling industry, but also a symbol of human creativity in solving the waste problem. In the future, as technology develops, machines like this will become more and more perfect and contribute more importantly to protecting our planet. Let's wait and see how far technology will take us. Thank you for watching the video. If you find it useful, please like, share, and subscribe to the channel so you don't miss the next videos. Don't forget to leave your thoughts in the comments section below. Now, goodbye and see you again.